Welcome back. On the line with us is Dr. Michael Mann, the Distinguished Professor of Meteorology, the Director of the Earth Systems Science Center at Penn State University, member of the National Academy of Sciences, recipient of the Tyler Prize, author of numerous books, including The Madhouse Effect, and most recently, The New Climate War. MichaelMann.net is the website. The Twitter handle is Michael E. Mann. And by the way, Dr. Mann, I've been digging into The New Climate War. This is an absolutely brilliant book, a very serious, thoughtful book. Thank you for it. Welcome back to the program. And I'm reading this story, Climate Change Makes Zombie Fires More Common, as if drought, flooding, extreme hurricanes, and deadly heat waves weren't enough. Climate change could make zombie fires more common. Tell me about these fires in the Arctic. They're calling zombie fires that just never go out.
Yeah, thanks, Tom. It's great to be with you, my friend. And this is one of the manifestations of human-caused climate change. We're seeing wildfires from the Amazon all the way up into the Arctic. It's making the planet warmer, drier in many locations. You put that together, heat, drought, you get wildfires. And even up in the Arctic, where they have seen very warm, very dry conditions in recent summers. And there is a huge amount of material in these environments, dead organic matter, peat bogs. There is lots of material there to burn. And so once you do get those fires going, there's just a lot of material to keep them going for some time. And hence, yes, climate change is indeed creating a zombie apocalypse. That is to say, zombie wildfires up in the Arctic.
And these wildfires are also converting stored carbon, forests, and I guess in many cases peat and permafrost, into atmospheric carbon, right?
That's true. And that happened down in Australia, where I was doing a sabbatical last year during what they now call the Black Summer, this summer where these bushfires blanketed the continent. Australia, during those bushfires, put more carbon into the atmosphere through those fires. In fact, more than 2 times as much carbon from those fires as all of fossil fuel burning for that entire year in Australia. And so this is adding carbon to the atmosphere. We think the Amazon, which has historically been a sink, drawing up carbon, burying it in old-growth forests and root systems beneath. That carbon is starting to be released. The Amazon could become a source of carbon within a decade or two if we continue on this road. So it's not a runaway warming scenario, as some have feared, but it will add to the warming. And it does sort of suggest that we may well find ourselves at the upper end of the projections of future carbon levels if we don't act dramatically now.
Yeah. And now, with regard to the melting Arctic ice cover, I'm reading that there's actually the possibility. I mean, many of the news stories have been, you know, all the oil companies and all the big countries, in particular the United States and Russia, are competing for the Arctic because, you know, they can drill fossil fuels out of the region. But there's also a rare cooperative note going into an Arctic meeting between us and Russia. Any word on this?
Yeah, so there's this Arctic Council that was set up a number of years ago to bring together countries that border the Arctic and have an interest in, you know, maintaining the health of that environment. And whether you're Russia, whether you're North America, Canada, the United States, Finland, the Nordic countries, we all, have a stake in what happens there. And in many respects, when it comes to what's happening in the Arctic, it's happening even faster than our models projected. The sea ice is disappearing faster, as you note, leads to all sorts of complications. First of all, it opens up the Arctic Ocean for oil drilling. We drill more fossil fuels, burn more of them. We contribute to the warming. Moreover, it creates a national security, a conflict issue, because pretty soon you have competition between different countries neighboring the Arctic for those drilling rights and for, efforts to defend these new coastlines from a defense standpoint, from a military standpoint. And so it's leading to all sorts of complications. And it's a reminder that uncertainty isn't our friend. In many respects, the impacts are playing out faster than we expected them to, with dire consequences.
Is there any new research on the clathrate gun hypothesis? You know, this theory that there are frozen methane deposits off the coasts of all the continents, and there's a pile of it in the Arctic, and that if this stuff starts melting rapidly as a consequence of warming waters, that it could, you know, tip into a runaway cycle. Do we have any idea how much warming it would take to trigger something like that? Apparently, that happened toward the tail end of the beginning of the Permian extinction.
That's right. There are periods in the deep geological past where something like that happened. Right now, we're not anywhere close to that. Right now, for example, the Arctic isn't as warm as it probably was during the end of the previous ice age about 100,000 years ago. We're in that neighborhood. There was no, you know, runaway methane warming that precipitated from that event. If we burn every fossil fuel we can find, if we continue with this profligate sort of burning reliance on fossil fuels and elevate, you know, CO2 concentrations to twice or 3 times pre-industrial levels, pretty soon we probably, you know, soon if we were to do that, we would get into that regime where we start to we set in motion some of these large feedbacks. Right now, there's no evidence that that's happening. We're measuring methane pretty carefully. It is increasing, but we're fairly certain based on the isotopic signature. We can look at the carbon atoms in the methane that's accumulating in the atmosphere, and the isotope of carbon tells us where that methane's coming from. Thus far, the methane that is showing up in the atmosphere appears to be coming largely from fossil fuel extraction, from natural gas, from fracking. And so far, the methane increase is actually something we can control if we do something about our, you know, continued extraction of fossil fuels.
That's good news and reassuring. California is heading toward another brutal wildfire season. Here in Oregon, where this state is in, I saw an article a couple of days ago suggesting that this might be the worst drought in the history of the state. We had horrible wildfires last year where for a week or two, Louise and I could hardly breathe. How much worse is this going to get?
Yeah, well, there's a little bit of bad news here. If you're in Oregon, if you're in the Pacific Northwest, we actually just published a study that was publicized today in one of the journals of the American Geophysical Union called Earth's Future, where we look at the climate model projections and their implications for heat stress in North America. And it combines the warming and the more humid air, the more humid the air, the more heat stress, and changes in population. And the Pacific Northwest is one of the hot spots where we expect to see more than a doubling of heat stress by the end of the century if we continue with business as usual. On the other hand, if we act, you know, now dramatically, we can prevent heat stress from getting significantly worse. So the future, to a large extent, is still in our hands. But hey, in the West, we've seen unprecedented heat and drought and wildfires. Back in the East, we've seen huge flooding events. This is dangerous climate change. It's arrived by some measure, and the question is, how bad are we willing to let it get?
Yeah, it's absolutely here. Michael, we just have 30 seconds. I understand the world's largest iceberg just broke off in Antarctica. What's the meaning of this?
Yeah, well, we've seen a number of those over the last decade or so. The Larsen Ice Shelf B, larger than the state of Rhode Island, broke off in 2003. And since then, we've seen these ice shelves begin to disintegrate. And that's a cause for worry. It means we are destabilizing the Antarctic ice sheet. And if we do destabilize those ice shelves, then that inland ice can start to flow into the ocean. And that's where we really start to see sea level rise, if we start melting the Antarctic ice sheet, if it disintegrates. So we still have time, hopefully, to prevent that.